In Module 5, we're going to start talking about trigonometry. And in this first section, we're going to review our right triangle trigonometry. So we're going to talk about right triangles and our trig ratios. So let's go ahead and review the parts of a right triangle. So the first part of the right triangle is the hypotenuse. And the hypotenuse is always the longest side. And it's always across from the 90-degree angle. So if we're looking at our triangle ABC, our hypotenuse would be side AB. So in a right triangle, the hypotenuse is the only side that we always know. It's always going to be in the same place. The opposite side and the adjacent side are always dependent on what angle you're looking at. But if we're talking about which side is the opposite one, we're always talking about the side opposite from an acute angle. And the adjacent side is always the side next to an acute angle. So if we take a look at our triangle and we look at angle B, its opposite side is going to be side AC. That's the one across or opposite from our angle. So this is the opposite of angle B. And its adjacent side, the one next to it, is side BC. So this is it's adjacent of angle B. If we look at angle A, its opposite side is going to be BC. So BC is the one that's opposite of angle A. And its adjacent side, the side next to it, is side AC. So side AC is adjacent of angle A. So the adjacent and opposite side are always dependent on which acute angle you're looking at in your right triangle. The hypotenuse is the one that always stays the same. So let's go ahead and review the 6 different trig ratios. So looking at a right triangle, our ratios are based off whichever angle we're looking at. So we usually denote that angle by theta. So once you've identified theta, you identify the opposite and adjacent sides of that angle and its hypotenuse, and you can set up your 6 trig ratios. So the 3 that are familiar should be sine, cosine, and tangent. Sine is the opposite over hypotenuse. Cosine is the adjacent side over the hypotenuse, and tangent is the opposite side over adjacent. So you may have heard this referred to as SOHCAHTOA previously to help you remember the trig ratios for sine, cosine, and tangent. The 3 that you may not be familiar with are cosecant, secant, and cotangent, and they are just the flips of our 3 trig ratios, sine, cosine, and tangent. So if we look at cosecant, which is abbreviated CSC, it is the hypotenuse over the opposite side. And if you look, that's just the flip of sine, or also known as the reciprocal. So sine and cosecant are reciprocals of each other. Next, if we look at secant, which is abbreviated SEC, it is the hypotenuse over the adjacent, which is the reciprocal of cosine. So cosine and secant go together. And then lastly, if we look at cotangent, abbreviated COT, it's the adjacent over the opposite, which is the reciprocal of tangent. So our 6 trig ratios, there's always 2 that pair together. There's the regular trig ratio and then its reciprocal. And we can use these to help find ratios in our triangle. So go ahead and do some examples. So given our right triangle, we want to define the 6 trig ratios for angle theta. So you need to identify the opposite, adjacent, and hypotenuse sides to our angle theta. So the side opposite is going to be the side with length 10. The adjacent side, it has side length 24. And our hypotenuse is the one with length 26. So all we have to do is write our trig ratio. Sine, which is opposite over hypotenuse, is going to be 10 over 26. And if you can simplify a ratio, you want to. So 10 divided by 26, both divisible by 2, simplifies to 5/13. Cosine, which is adjacent over hypotenuse, is going to be 24 over 26. Again, that can simplify, both divisible by 2. We get 12 over 13. And then tangent, which is opposite over adjacent, would be 10 over 24, which we can simplify as 5/12. And then to find cosecant, secant, and cotangent, we can just do the reciprocal for sine, cosine, and tangent. So cosecant is the reciprocal of sine, which means it's 13/5. Secant is the reciprocal of cosine, so it's going to be 13/12. And cotangent is the reciprocal of tangent, so it is 12/5. You can also find these ratios using the definitions from the previous page. So cosecant is going to be hypotenuse over opposite, which is 26 over 10, which simplifies to 13 over 5. Similarly for secant and cotangent. So if you can't remember which one it's the reciprocal of, you can always use its ratio from our first page to help you with the ratio. Let's move on to our next example. So we want to find the 6 trig functions for angle A. So I'm going to denote angle A as theta. And before we can start finding our trig ratios, we actually need to finish finding our missing side. So let's go ahead and identify our 3 sides. So side BC is going to be the opposite. Side AC is our hypotenuse, and side AB is going to be the adjacent side. So we need to solve for the adjacent side of our hypotenuse. And the way we do that is by using the Pythagorean theorem. So a squared plus b squared equals c squared. Where a and b are the legs of our right triangle and c is always the hypotenuse. So it doesn't matter which letter we choose to solve for, whether it's a or b. So I'm just going to leave a as our missing side AB. So we end up with a squared plus 50 squared equals 60 squared, which becomes a squared plus 2500 equals 3600. Next, we're just going to subtract 2500 from both sides. And 3600 minus 2500 is 1100. So we get a squared equals 1100. And then we want to take the square root of both sides. Now 1100 is not a perfect square. So we want to simplify it. So I can break down 1100 as 100 times 11. And I know the square root of 100 is 10. So we're going to end up with 10 square root 11 as the length of our missing side AB. So I'm going to mark over here 10 square root 11. So now that we have all 3 side lengths, we can go ahead and set up our 6 trig ratios. So sine, which is opposite over hypotenuse, is going to be 50 over 60, which we can simplify as 5/6. Cosine is adjacent, so 10 square root 11 over our hypotenuse 60. And while we can't simplify the square root of 11 with anything, we can simplify 10 over 60, which is just become 1 in the numerator times the square root of 11 over 6. And then tangent, which is opposite over adjacent, which is 50 over 10 square root 11, which become 50 over 10 simplifies as 5 over square root 11. Now, if you remember, we don't like to leave square roots in the denominators of fractions. So I'm going to rationalize the denominator by multiplying the top and bottom by square root 11. So my tangent ratio is going to become 5 square root 11 over 11. Now for cosecant, secant, and cotangent, we're just going to do the reciprocal of the fractions we just found for sine, cosine, and tangent. So cosecant is the reciprocal of sine, so it's going to be 6/5. Secant is the reciprocal of cosine, so it's going to become 6 over square root 11, which when rationalized is equal to 6 square root 11 over 11. And then cotangent, if we use our first trig ratio of 5 over square root 11 into the reciprocal of that, we get square root 11 over 5. And those are going to be the 6 trig ratios for angle A in our right triangle. Our last example is given cosine of angle A is 3/4, we want to find the other 5 trig ratios. So in order to find our other trig ratios, we need to set up our right triangle and label what we know. So I'm going to label my sides A, B, and C. So we're talking about angle A, so I'm going to denote it as theta. We are given the cosine. So if we label our 3 sides, opposite of angle A, adjacent of angle A, and the hypotenuse, cosine is the adjacent over the hypotenuse. So I know the adjacent side is 3 and the hypotenuse is 4. So to find our other 5 trig ratios, we first need to find our missing side length. So if we set up the Pythagorean theorem, a squared plus b squared equals c squared, plugging in b and c for our given sides, we have a squared plus 3 squared equals 4 squared. It's going to become a squared plus 9 equals 16. Subtract 9 and we get a squared equals 7. Take the square root of both sides and we get a equals the square root of 7 since it does not simplify. So I'm missing side over here. It's going to be the square root of 7. Now that we have all 3 sides of our right triangle, we can go ahead and find our other 5 trig ratios. So starting with sine of angle A, which is opposite over hypotenuse, is going to be square root 7 over 4. We already have cosine, so we move on to tangent of angle A, which is opposite over adjacent. We get square root 7 over 3. And then we need to do our 3 reciprocal trig functions. So if we start with cosecant of angle A, which is the reciprocal of sine, we get 4 over square root 7. Secant of angle A, which is the reciprocal of cosine, we get 4/3. And then lastly, cotangent of angle A, the reciprocal of tangent, gives us 3 over square root 7. So I hope that this was a quick review of the 6 trig ratios. We are going to be doing more with them later on in the module.